Hello and welcome to the Visionless Designs YouTube channel, the channel where you get to see all the things I can't. So today we're back at the kiln. In the previous one we upgraded the ventilation system and the fans, and I figured I should do an update and go over the findings we found, especially when it comes to the ventilation, because we had a bit of an experiment and found the different methods to do it. So we'll have a go over that now. When we first built the kiln, we only had this one vent on the side here. So this is directly opposite the kiln unit itself. The actual internal size of the kiln is 12 cubic meters, which can take up to 6 cubic meters of wood. So quite a big thing. And I got recommended just the one vent. It's a 4-inch vent with an adjustable in and out here. In the end, this was not enough for the amount of moisture that was coming out, and it was actually better just getting rid of this completely when it's full going and just leaving the vent open. There was a heck of a lot of water coming out of that. And this, even when it's open, still not enough, so we've had to modify it. I'll go see what happens with that now. On the back here then, we've got the extra vents. So originally, these vents were from 2 fans I had in that I felt were not providing enough airflow on the inside. So we put 2 bigger fans in, which you can see in a previous video. And instead of filling the holes in, I decided to turn them into vents as well. So we've got one at the top there, one at the top here, one down here, and one on the bottom there. Obviously, with having all these extra vents in, it gave me the ability to experiment and see what methods actually worked. I found that quite confusing when trying to build this thing, because I had different people saying different things. You should only have the vents in the top, you should only have the vents in the bottom, you should have vents in the top and bottom. Well, now I've got top and bottom with the ability to knock them off individually. And also, as I showed in the previous video, I put these ThermoPro sensors in there in different places. So I'm able to monitor the humidity and temperature at different points in the kiln, so we can see what actually works. Obviously, with having all these extra vents in, it gave me the ability to experiment and figure out what actual method is best for the kiln. The other thing we also had, as shown in the previous video, is sensors in different parts of the kiln, which allows us to monitor the kiln temperature and humidity at different points. And also I've got the kiln electric consumption monitored as well, so we can monitor everything and see just what the right method is for efficiency and, well, what works. Obviously, having all these vents in the kiln gave me an ability to experiment and see which method people suggested is the actual best method. I also have, as shown in the previous video, the ThermoPro sensors placed at different points in the kiln. This allows us to monitor the humidity and temperature at different points to make sure that everything is equal, and if any humidity is escaping, well, see if it's actually escaping. The other thing we've also got is the kiln has an electric usage monitor on it. So with all the changes, we can also see just how much extra it's costing us in electric. So, right, we'll have a quick go over what the experiment entailed now. So in the first experiment, we had all the vents open, so the 3 vents at the top and the 2 on the bottom. And what we found with that was the electric consumption was at 1 kilowatt, and all the vents were producing water when it first opened. Bear in mind, it's at 50 degrees Celsius. And what eventually happened was the bottom of the kiln got cold, and we realized that what was happening was there was convection going on, so all the hot steam and hot air was coming out the top vents, and it was then drawing in cold air from the bottom, which was very evident because the bottom vents were dry. So bottom of the kiln was getting cold and costing me more in electric. So it was lesson learned there. Don't have vents on bottom and top, because it's going to cost you more in electric and it's going to draw in the cold air. In the second experiment, we used just the 2 bottom vents. So we completely blocked up the top ones and opened up the bottom 2. In fact, we did that. So what happened in this was the electric consumption went down to about 600-700 watts, and there was a good amount of water running out of them, but the humidity was constantly high. So although it was dripping out, it wasn't really coming out very efficiently. The problem we were finding is, because the humidity wasn't dropping below, I think it was constantly 95% plus, that causes problems when you've got 50-degree heat, which isn't enough to kill bugs, and high humidity, because it promotes bacteria, and therefore we could get a lot of mildew in there. So although it was cheaper on electric, and there was some coming out, bottom ventilation, just as far as I'm concerned, not worth it at all. In the second experiment then, we completely blocked off the top vents and switched to just having the bottom vents open. We in fact just took them out completely and had them like that. So in this instance, the electric consumption went down to about 600-700 watts of electric, but the humidity stayed high. There was still a lot of moisture coming out of these, but the problem was, as we were looking at the humidity sensors, the heat was staying in the kiln, which obviously was rising to the top, but all the steam's in the top of the kiln as well, so it's having to build up pressure until it eventually forces its way down and out, which means that the wood in the higher levels above these vents is in a perfect condition for mildew growth, which is, 50 degrees and high humidity. It's like 95% humidity. So it's not really worth doing it on that basis. You need to be able to let the steam out. Because steam rises, you need the vents in the top. So yes, this costs less in electric and you save heat, but you're not getting the moisture out, which is the whole point in this. The last experiment we did, experiment 3, was bottom vents fully closed and all the top vents open. Again, we ended up taking these out just because the amount of water coming out was, these were just causing a blockage. So they're not worth using in the end. If you just want to stop something coming out, then fine. But for limiting, I mean, it was just leave the pipe open. In this case, the humidity went down, so as it was all drying, it was around 85%, 80 and 85. The bottom of the kiln was warm, so it's the same temperature as the rest of it, and same humidity. The electric consumption was 800 watts. So yeah, this is definitely, you want plenty of vents in the top of the kiln, don't want any in the bottom, as I said about convection. And yeah, this was literally, unfortunately didn't get a video of it, but all 3 vents on the top had water almost running out of it. So yeah, quite a bit. Obviously, this experiment would not have been possible without the sensors in the kiln. So as you can see here, we've got the sensors placed in different parts of the kiln. If you're going to build one yourself, I would highly recommend getting something like this put in. I've got 3 sensors in. I'm contemplating putting an extra 3 in, but for now this has proved exceptionally useful because we can monitor the humidity and the temperature. So for example, if the thermostat on the kiln unit breaks, we can see that immediately and take care of it. Or if the humidity is not getting out, then we can take care of it before the wood goes mouldy. Again, another key thing about the sensors in the kiln is it allows you to obviously see what the humidity is, which gives you a good general idea of how dry the wood is. So when it's at 50 degrees C for the softwoods in here, we wanted to get it down to about 20% humidity, which sounds high, well, sounds low, but you got to remember humidity, relative air humidity is different depending on the temperature. So when you drop the temperature down, the humidity is going to start going up. So it could go down to, well, sorry, the humidity could go up to about 60%. So you just got to keep that in mind. Yeah, when we experimented with this, obviously it's not as good as if you have an actual moisture meter into the wood to monitor it and see what they're going at, but it does give us a good general idea of how much moisture is actually being released from it. Obviously, the lower the humidity, the less moisture is being produced. So the closer it is to being fully dried. So that's my take on the kiln ventilation. As I said earlier, yeah, definitely want to get some sensors to monitor everything that's going on in there. And again, just so everyone's clear, the best method I found was vents in the top, and plenty of them, because the ventilation in the bottom was either cooling the kiln down or was causing the rest of the wood to develop mildew, as it wasn't letting out enough humidity. So if you have any questions, please don't hesitate to ask below, and I hope you found this useful. Okay, thanks for watching the video. Hopefully you enjoyed this. Don't forget to check out the website visionlessdesigns.com, where you'll find all my products which will help support the channel, as well as links to my social media and Etsy store. Links are also in the description below, and please don't forget to hit that subscribe button on the end. Apparently it's really good for me, because it's good for everyone, like cookies. Cookies are good, aren't they? I think.